All right, y'all. What we're gonna do is talk about how do you know when you are dealing with growth or decay, just based on the function. So let's go back here a little bit. And we talked briefly about what growth and decay is, some real life examples of that. So hopefully you remember a couple of those. Exponential growth, one of the main ones we'll talk about would be the value of something that appreciates, like a house or an investment or population or bacteria growth, something like that. Decay, most of the time we're talking about an element or something along those lines. Maybe even the value of a car as time goes on. So let's go back to this right here. So how do you know whether you're dealing with growth or decay? So it's all about that B value. All right, and here's your exponential growth function, and the B value is the number with the exponent on it. Notice that's down here, that it's highlighted. When you're looking at an example and you're trying to decide whether it's growth or decay, for your growth, the B value is going to be greater than 1. So we're looking at things like y equals 3 to the x. So notice that I don't have a value there for A. But it is there. It's just a 1. Another example would be something like 2 times, I'm going to be a little bit tricky and sneaky on this one, 3 over 2 to the x. That one has an A value of 2, and the B value is 3 over 2. Oh, no, Miss Brown, that's a fraction. Are you sure that's growth? Yes, I am, because A is not dependent upon that. It's all about B. And B is 3 divided by 2, and that's 1.5. That is still greater than 1, so that is still growth, right? So on the opposite end of that, we've got decay. For a graph to be considered a decay function, the B value needs to be between 0 and 1, but not equal to one of those. It's strictly between that. So you won't ever see anything like y equals 1 to the x, because that wouldn't be growth or decay. That would just be a constant. 0 to the x, well, that's just kind of a tricky one anyway. We won't go there. But for your B value, how about 1/4 raised to the x power? That would be an example of decay. Then we could mix it up and give us an A value of 3. What about 3/5 to the x? And then we could even add a 7 to that. Now, so it's all about the number with the exponent on it. That tells you whether you're dealing with growth or decay. So let's scroll down here and do a few examples looking at these. So what I want you to do is look at the equation, figure out what the B value is in each scenario. Is that growth or decay? And then we're going to talk about what the shape of that graph would look like. We're not going to sketch it yet. We're just talking about the shape. All right, so for this one, remember your general equation would be A times B to the x exponent plus D. So we're looking for the thing with the exponent on it. So number 1, the thing with the exponent on it is 2. So that's your B value. Is that growth or decay? Growth. It is bigger than 1. And the shape of a graph of exponential growth would have this general shape to it. Number 2, what is the B value? 1/2. It's the thing with the exponent on it. That would mean this is decay. And the general shape of a decay function would be, we start out with a lot, and as time goes on, we have less. So it's the opposite of what growth looks like. Moving on to number 3, the thing with the exponent on it is 3 over 2. Now, we kind of already looked at that. Remember, 3 divided by 2 is 1.5 or 1.5. So even though B is 3 over 2 and it is a fraction, it is still considered growth. And again, it would have this general shape. I've got 2 more. So number 4, a B value is 3. And that's another growth. And it would have this shape. All right, and lastly, 5 over 2 to the x power. Real heavy on growth here, right? So that would be another growth. And it would have this shape. All right, how could we turn that last equation into something that was decay? What could we do to make this decay instead of growth? How about we flip that fraction? 2 over 5. Now, if we divide that out, that'd be roughly 0.4. Well, exactly 0.4, actually. And that If that was the case, that would be a decay. All right. So there's some examples on how to determine whether you're dealing with a growth or decay function